MC-10 Club Extravaganza. So now, let's go to here. On the MC-10 Club, I introduced this little graphical design that can be created with the semi-graphics mode on kind of like a useless font, and I used the MC-10 graphics tool to create it. And then I was thinking the other day I could do this also, which is kind of a special little demo type screen, you know, where and it doesn't take a ton of code to do this in BASIC. And so I got the idea of an animation of these bars just kind of rolling across the screen. So after I pick, you know, like each one of these is basically just a binary number, and because they didn't have room, there's 8 bits on these fonts, and the 8 bits go from 0, you know, theoretically to 255, but they didn't put them all in there, and so they had to take out half of them. And so what they did is when you hit bit or byte number 64, they jumped it ahead. They basically inverted the code. Instead of it being bit number 7 that's on, all the other bits are on, which means that if you add it up, if you take the decimal number of this one, which is 64, and you convert that to binary, it should be 0000010, which means that if I select this over here, 64, it should be exactly opposite of what's shown here. These are 1s, and this right here is a 0, and this is a 1. So let's see here, calculator. So it's not that. Now if you take their number and whoops, clear, there it is. We go 1 0 1 2 3 4 5 6, which is a total of 8 bits. We convert that to decimal, we find out that that would be 191. And another curiosity is they did several things. This particular one is byte number 127, but as you can see, it's not 127. It's 128. So there's some distinct changes they made in these. I haven't checked them all, but there's some exceptions. Basically, it just makes it more difficult to calculate. If it was binary, it'd be pretty straightforward. But it's and then since bit 7, bit 7's off, you have to skip that. That's why it's just a slight little gap right there. On this one, there's a little gap, and down here there's a little gap. But when you see it just rolling along, it doesn't really show up that much. It skips from bit 32, and there's no 64-bit, to 128-bit. And 128-bit is achieved through displaying number 127. So those are the ones I'm using on this. And if we go to the emulator, right here, load the emulator, run, and QuickType. And I called it Hypno, so we'll load in Hypno. Right now I haven't finished it, but I've gotten most of this done that I had planned to do. I'll show you what this does. Run. Okay, right now I got a poke 49151, 4 to put it in semi-graphics mode, the one we need. And as you can see, it is slowly shifting over one by one. This is written in BASIC, and it's pretty fast for BASIC, but it's still obviously kind of agonizingly slow in the big picture. Now, so I thought, well, why not write some code in machine language? So I did that. Here it is. Or I'll show you this here real quick. This is in TASM. This is what you need to write in order to create a binary file. Okay, so back to this code here. And this is a very quick and down and dirty code. Origin is 20,480. It's above basic. It's past basic. It's out of string space. It's what you might call probably safe. It's safe, but this could be changed eventually, to wherever I want. So anyways, start. This is where our program starts. Right now I skipped this other stuff because I was debugging, and I just wanted to show you what I've achieved so far. So first of all, it goes to jump out 8, which is down here. It skips all this stuff for now. It goes to out 8. It loads X. It's a very small program here. This is it right here. From here to here. Okay, it just jumps down here, loads X with 16384, and X is the indexing. It's an index register. Yeah, I'm trying to think about what exactly that is. Okay, so then A is an accumulator, and it loads the contents of A with the address of X, which is the first position of the screen. And that, it compares that with 127, because guess what? 127 is actually 128. So, and I'm trying to shift it to the left, which means 127 has to become 1. And then I store that at X. If it's not 127, it skips that, and it checks for 32. 32, remember I told you that there's no 64-bit, so I have to make 32 skip to the 127-bit. If it's not 32, as it says here, branch if not equal, just like up here, branch if not 127, it branches down there. And if it compares 32. If it's not 32, it branches down here. Now, if it's not 127 and it's not 32, it's whatever other numbers there are, like 1, 2, 4, 8, 16. If it's 1, 2, 4, 8, or 16, we can roll that memory location pointed to by the index register. So roll, basically write it's a roll left, basically, or yeah. Anyway, so rotate left, and so it rotates the byte left. And then I had done that without a CLC, but this roll instruction uses the carry code in the condition register, and the C is carried to the lowest register. I mean the lowest bit. Yeah. So the lowest bit is loaded. If the condition code register turns to a 1, that's actually loaded into the least significant bit of where X points to. Yeah. So that was changing my numbers to who knows what, and it was pretty exciting to look at. It was a mess. But so then I looked up the instruction: clear the condition codes register before you roll rotate left. And then down here, we're going to add X. We'll compare it to the past screen memory. And if it's less than that, we know it's on screen memory, and we go back to out 9, which brings us back to load A, and it flows right through the screen. And it loops through this, loops. But there's no way to get out of it. I didn't put a key code to break us out of it when it's done either. So now we can see this in action by coming here. We showed you basic. This is how fast basic is. Now I'm going to stop basic. I'm going to go back to the regular screen by punching in sound 1, 1 instead of doing a poke 49151, 0. So sometimes sound is easier to do to get back, because it automatically puts you back into this screen mode. Okay, so now we're going to take and we're going to load the binary, the file that I generated through TASM. I'll show you how that's written. Let's see, TASM -68 -B for binary, 6800 -B is binary, -X3 is the extension of the special extension of 6803 instructions. Has some added instructions, and then it's HipnoML for machine language .txt, and it's going to create a binary file called HipnoML.bin, which is now, and if I enter that, it'll be fine. It'll pass through with no errors. And now I'm going to load that. There's the name of it, Hypno Machine Language Open, and we're setting the execute to 20480. Now that's done. Now I'm going to list through 100 because I need to change a line in here, which is 50, because it does a loop to go back and keeps doing it over and over and over. So I'm going to send it to execute, and it's going to go from the slow. Let's see, if A equals -4, then execute, enter, and then we'll go list through 10, and I'll put in a 6, poke 49151, 4, and CLS : run. Okay, so now everything's ready. We got our machine language program loaded, we got our basic program loaded, and you get to compare the speed here. And run. It's got to shift through each bit until it's all the way through. There's 7 of them. And there it goes. There is the machine language code is now firing. Hypno. So now the reason why I'm making this is because I realized, well, earlier this was an experiment, because I realized that there is some code that could be written, and I haven't written it yet, that could cause text to scroll across the screen exactly the way this pattern is scrolling across the screen. So I thought that was intriguing. So if I put it in the full screen, you won't be able to see it because it has a weird, it just shows small. I've tried that before. So, okay. Let's see if I can think of anything else here. So there's the finished product, not really finished because I didn't put it in one packaged program, but just shows some potential. And then here is the text in this done in the same screen mode. And let's see, here is the assembly code that was written, and the MC-10 graphics tool that I used to create a lot of my designs of graphics in order to experiment around with things that are difficult to experiment around with. If you're doing it on the MC-10, it can be kind of difficult to visualize. This is easy to visualize, and one reason why this is easy is if I click this button, Show Grid, it allows you to see where you're at. There's some features that I wish it had that it doesn't have, but that's pretty useful. So that's it for today on this, and see you next time.